.NET 6 using Onion architecture, part 2.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Today we're doing part 2 of .NET 6 using Onion architecture. We laid out the core project, the first unit test, we did the private build, and so today we're going to review those builds, get them working on Windows images, and show you the difference between GitHub Actions and Azure Pipelines, and show you the differences in speed, the YAML format of both of them, and then we're going to go into documenting and diagramming our architecture for this church bulletin application. And stick with it. Feel free to fast forward through a few slow-moving parts, but it's so important to communicate to future team members what your architectural decisions are. And so you may think, oh, why do I have to document or diagram or sketch out my decisions about how I'm going to use this application, where I'm going to host it, the structure of the Visual Studio solution I'm going to have. But you do this one time at the beginning of a project, and then just incrementally as you make architectural decisions, and anybody else that comes to contribute to the software, they immediately understand what the overall intent is, because you have a vision in your head, but on day one, you only have a little tiny bit of code. And on day 2 and day 3 and day 4, it's going to be a while before your full vision for the software is realized. And so you need some communication tool to communicate what the vision is so that anybody working on the team can help break things down. So we're going to move through that. We're going to introduce you to Philip Christian's 4+1 architecture diagram format. We're going to also introduce you to Simon Brown's C4 architectural diagrams. Those are probably the two most widely used mechanisms for going from high level down to detailed architecture and design diagrams. I'm going to show you PlantUML for creating diagrams that you can save in a Git repository that are text format. They're not markdown, but they're pretty similar in a textual format where when you make a change to them, you can diff them and you can see them. They're friendly to pull requests. And then there's some very, very simple tooling in VS Code that allows us to automatically generate an image diagram from the textual representation. And so we're going to go through that, and we're going to create the architectural diagrams. We're going to create 5 layers of blueprints, architectural blueprints, 5 layers of architectural blueprints describing what we're going to end up with this church bulletin application. And so feel free to fast forward through a few places because I show you every detail. You are literally watching me program. You are programming with Palermo, and I'm doing the programming, and we're going to move through it. And so this is part 2 of .NET 6 using Onion architecture. And so let's get into it. So let's review the builds we have going. And part 1, we configure the GitHub Actions to run our build file, and we left it off, and we have 4 of these builds that we've run in GitHub Actions on the right, and then we have the builds that we've configured with Azure Pipelines on the left. And so you can see a number of times that it's been run. The Azure Pipelines is faster for the exact same build, and I'll show you this as a review in a minute. We've configured it to run on Windows agents, which we're running a PowerShell file. We're running some Windows commands, inunit.exe, things that are for Windows. And under the covers, the actual computers that are running these builds in GitHub Actions and Azure Pipelines are from the same data center in the same pool when GitHub was acquired by Microsoft. That's one of the things from Microsoft that was leveraged. The actual pool of build runners that was a part of the Azure DevOps product were used for GitHub Actions. Now, since then, the images and the containers and everything on them, GitHub has changed quite a few things, but the actual infrastructure is architecturally in the data center the same. So it's interesting that we have different runtimes. We have 1 minute and 19 seconds to 1 minute and 35 seconds. in Azure Pipelines. And we have at the fastest 1 minute and 40 seconds to 2 minutes and 37 seconds in GitHub Actions. So running this same .NET 6 build, very small, just the core of Onion architecture with our core project and running a single unit test, Azure Pipelines is quite a bit faster. And it's just the overhead of GitHub Actions and spinning up a container and getting it ready and installing everything, whereas Azure Pipelines is a lot more prepared with images ready to go for .NET software. So GitHub Actions is still early. There's a lot of people that are trying out GitHub Actions, and so I just wanted to show them both to you. Both of them are fine. Heck, JetBrains Team City is perfectly fine. It doesn't have a cloud offering that is as mature as these, but again, a build server these days is a build server. You just need to get one that works and make sure that you're running your build script. So let me just show you what the build script looks like. We're going to view the file. It's over here, and also I'm going to show you. Actually, I was already in there. I'm going to show you the pipeline here as well. Okay, so we can see that the YAML file is very similar, but YAML is not YAML. It's kind of like XML. You can say, oh, I know XML. But that doesn't mean you know any syntax. You know the structure of HTML. Just like if you say, I know JSON, that doesn't mean you're going to know one particular product's JSON format. So on the left, we are using the Windows latest pool. We're triggering automatically on the master branch of our Git repository. Same thing over here. We're going to, on a push to the master branch, we're going to trigger. We are going to run on the latest Windows latest, and then the checkout in Azure Pipelines, checkout is kind of implicit. You don't have to say check out the repository. Whereas over here, we're going to actually do, we're actually going to check out. We're going to tell the runner, hey, I want you to set up .NET because not every Windows over here on GitHub Actions actually has .NET. And then we're going to use .NET version 6, and we're going to run private build.ps1. And this is the syntax to run a PowerShell script. In Azure Pipelines, we have a task for PowerShell, and we're going to be running the build ps1 file with the private build, which private build.ps1 just internally calls build.ps1. So it's the same thing. But you see over on Azure Pipelines, there's a lot more things that are optimized for .NET developers. Whereas on GitHub Actions is a little bit more generic and kind of trying to support every programming language under the sun, so they don't particularly optimize for any one of them, whereas Azure Pipelines does do a lot more optimization for .NET. So I wanted to show you both of them because it doesn't really matter. It doesn't really matter which one you use. What matters is you have your own private build. And so as we kind of go back to our Visual Studio solution in the current state, we have the core of the start of Onion architecture. We always start with a really clean class library. It doesn't have any dependencies except for the kind of the basics, and that's that. So we're going to extend this by adding on some integration tests with our Onion architecture. We're going to discuss how to plan our architecture before we get into the integration tests. So in order to plan our architecture, we want to kind of cast a vision. In order to do that, we have to draw something. And of course, you can draw on pen and paper and share diagrams and whiteboard photos, and that's great. What I want to share is just kind of how you should think about it, what nature of diagrams to think about, and then we'll get to fleshing out the rest of our Visual Studio solution using the 4 tenets of Onion architecture. So I want to discuss the C4 architecture and the 4+1 model of architecture. These are both models that are used by a lot of people. In the 1990s, there was a white paper by Philippe Christian, and he coined 4+1 architecture, and it's basically different layers of blueprints and you have the physical layer, you have the logical layer, the process layer, and the development layer. And with C4, kind of has the author has layers, but it's different. It's the system layer, the container layer, the component layer, and the class layer. I've interviewed both of these on the Azure DevOps podcast, and I just wanted to share those URLs with you. I'll put them in the show notes. But Simon Brown created the C4 model, and Philippe Christian created the 4+1 model of architecture diagrams. And both of them are in the archives of the Azure DevOps podcast. Simon Brown back in 2020, and Philippe Christian actually just a few weeks ago. I was really excited to get him on the show because he's been a really strong leader in the industry for many decades. And so, but anyway, I encourage you to read up about those. I'm just going to show some examples now. So let's get into it. And as with everything, I like templates. Here's our working directory. And so what I like to do is create an architecture folder, and then inside the architecture folder have some diagrams. Now, I am going to start out with some templates, and if you have never heard of the file we're using, PlantUML, then this is going to be an interesting experience for you. But if I was to, let me just open up one of these, open it in VS Code, and you can see what the format of the file looks like. You can kind of see that we are defining that we have, Azure DevOps is going to go to Git, and of course I can trade out GitHub Actions, and then we're going to build, we're going to push, we're going to deploy UAT, deploy to production. But this is a diagram that is text in nature. If I hit my Alt-D shortcut key, it generates a diagram for me straight out of the text. So, and of course we can export an image. There are some free and open source tools that you can integrate with your build to generate diagrams and save them every time someone pushes or does a pull request, and you can do that. But basically, we have the programmer up here using the Azure DevOps project, committing to Git, integration build, three different environments. This is a template. We're going to come back to this, but we will be setting up and installing our software on 3 different environments. But before we do that, I'm just going to show you kind of what these different levels are and how to use this tool. So another helper that I'm going to put in here for you is PlantUML setup. And of course, you just open it up in terminal, say PlantUML setup, and run that. Of course, I've already run it. What it does is just execute a few more commands internally. And what we're going to do here is it does a Choco install for the Java runtime, which is used by the graphic generator. Then GraphViz is a library that also has to be used. And then if you don't already have VS Code, it's going to install VS Code because PlantUML is a plugin for VS Code, but it needs these extensions. So PlantUML. There we go. And you can see we already have it. We already have it installed, and there's a shortcut key, Alt-D or Option-D on the Mac, and it supports file extensions of .pummel, .plantuml, .iuml, all that. Okay. All right. So let's go ahead and close these out and just run through the different diagrams. Okay, we're going to start with so the 4+1 development template. I found that the system diagram of C4 can be used pretty much the same as the kind of physical and logical of 4+1 put together, and then the container level is good to visualize what the different deployed components are going to be in your application. Are you going to have something on Azure, on a Windows servers, in Azure container apps? And then the component level of C4 is good for the logical layering of your Visual Studio solution with the different project dependencies and libraries that you choose to use. And then the class level, which is the 4th, is good for your domain models to show your entities and your aggregate roots and value objects and message types, commands, queries, handlers, and then other within that do any sequence diagrams or whatever is appropriate for yours. So let's go to the system, and these are template files, but we're going to use them. And so I'm going to open this up, and this is very small. We have a person, we have the system, and then just some external system, and then we've created relationships between them. So Alt-D is going to be here. Okay, and notice that it's a simple diagram. The person, the system, the external system. Okay, so if we go to the container, and very similar, by the way, this is the comment. We're commenting out left to right direction, but I leave it in there because oftentimes I switch it based on how it tends to lay out the graphic if I want to change things, same with the scale. And of course, this right here is kind of like a using or an include URL directly from probably the most popular repository and maintainer of these files. But if I do Alt-D, we can see that this container diagram has a person that is using a particular running process that's a container. Think of a web application that's running, and it calls into, I don't know, maybe a web API, and the web API calls into something else, and that something else calls to an external system, I don't know, like Twilio to send a text message or something. All right, then the component diagram, that level, it defines container boundaries and whatnot, but sorry, yeah, these are, let me just go back, container, system boundary, the container, okay, and Alt-D, I might have labeled these wrong, container versus component, but it's just a different style. So we can see that we can model a database. All right, let's go to our class diagram. And we can see that we're defining some classes, some types, some relationships, an enum, an interface up here, Alt-D to show the diagram. And we can see that we have some entity with properties and methods, and it can, whatever we want there, and some base class, inheritance relationships, usage relationships, things like that. Okay, so now that we've done this, we are going to start to talk about our first feature so that we can visualize what this application needs to be, so we can choose some architectural elements to introduce. So let me go to our GitHub issue that we're working on, and let's just frame it out. Okay, so create the new onion architecture foundation in .NET 6. I think we have done that. So add integration tests through GitHub Actions. In order to define what first test we need, we just need a little bit of information. So the application is a church bulletin. It's digital signage for screens at the front of the sanctuary, and it's also going to generate a PDF for a printable bulletin with everything that's going on that particular Sunday morning or during the week. And so let's just frame out an example, and that way we can introduce the first architectural elements. So if I was to just write here in a bullet list, for a printed example of a Sunday bulletin, I might say, you know what, it's going to be Sunday, December 25th, or whatever date it happens to be, and then I might say, okay, we have a 9:30 a.m. Time slot, and then we have a 11 o'clock time slot. That's pretty common, but whatever the time slots are, this is an example. Okay, and then we have, all right, so the first thing at 9:30, let's say you have the worship service, and that's going to be that's going to be in, where's it going to be? The sanctuary. And then we also are going to have the, I don't know, Genesis Bible study class. All right, and that's going to be in, let's say there's a room 205. Then there's going to be, you got your youth group or your youth ministry, and that's going to be in the high school room. All right, so that's happening at 9:30, and then at, you can indent that, and then at 11 a.m. we're going to have the worship service with the choir, and that's also going to be in the sanctuary. Oh, I spelled that wrong, didn't I? Somebody should have said something. All right. And then we're going to have, I don't know, children's church, maybe. And that's going to be in the children's building. I don't know. And then we're going to have, I don't know, the newlywed class. And that's going to be in room 104 or something like that. Okay, so imagine a bulletin. So now we need to design our model like that. Let me just go ahead and comment. We're going to design our model, and in order to do that, we're going to create a new class diagram. All right, so let me copy, let me paste in here, and this is going to be domain model. Let's get the start of this. And let's go ahead, as we commit this, I'm just going to demote the rest of these to a templates folder. Okay. Now if I come back up here, do a commit, I like Tortoise Git as well, just to be able to have this. And so we're working on issue number 3. Added puddle templates. Okay, commit and push. There we go. Oh, because I modified the GitHub Actions, I have to pull in order to get the workflow actions, and then I can push. So sync and push. That's something we get if you do any of these YAML buildings. It actually does a commit to the Git repository, which then means you actually have to do a pull to your local repository, because Git doesn't know that it's just a GitHub action. It's a new commit. You don't have that commit, so you're behind. Okay, so now we have our class diagram. Let's open this up and define it. Okay, so class diagram, our domain model. Let's just C4 architecture, church, bulletin, domain model. And put that in both places. All right, so the first one, we're gonna start, what do we actually need in order to just start thinking about this? We need a place to store data. We have the decision, is it going to be a single user interface, or is it going to be a multi-user interface? We actually don't have to decide that just yet, although it's going to be a multi-user. We're going to want at some point to web enable it, to smartphone enable it. It's not just going to be a standalone desktop tool, so it's going to be run somewhere. We don't want to put a server at the church. Well, and so we're going to put it in Azure SQL to store data. And we're going to have one of the app services, whether it's App Service Web or whether it's App Service Containers. We're going to choose one of them. So we have an entity, and in order to make a bulletin like this, let's just start out with a very simple model, and we can add as it goes. This will illustrate adding on the rest of Onion architecture. Let's call it let's see, we have a worship service, we have a place, we have a time, we have a name. If we group by time and date, then, okay, let's have a scheduled gathering. Let's just call it that. And let's say we need the date. Okay, so this is going to be date. I'm not going to worry about actual types and libraries. We're probably going to end up using Nota time just for good dates and instances and all that. Date, the date might also be the time, but let's just say for now, yeah, time. We might combine them, but for now, let's leave them. Okay, and then we're going to say the name of the gathering, and that's going to be a string. String. IntelliSense is trying to help so much. And then place, and it could be the room number. But you know what? For now, let's make it a string because we're not going to catalog the rooms just yet. We don't need any methods just yet. And so let's just go ahead and get rid of the rest of this. We don't need the interface. And if I save it, Alt D. Okay, that's our class. That's our class so far. But we also want to be able to save it. And this is what we're going to need in our next part. We're going to throw together unit tests, data access, SQL, database migrations, entity framework. But this is how we model it. All right, so that's our class. Let's go ahead now. Close all these. Let's go ahead at this point and let's model out our next one, which I think we're going to go ahead and let's go ahead and look at this one. System boundaries with containers. No, let's do a component diagram. We need to dive into a container. So we go to components to dive into containers to lay out our Visual Studio solution. Okay, so actually, no, I'm doing it in my head. I need to show you guys. I need to show you guys the whole kit and caboodle. So I'm going to copy this template, and this is going to be our system diagram. So system for, yeah, just system. Okay. All right, so system diagram, title, church bulletin, system diagram. Okay, so let's just call this, somebody's going to use it to configure this, and let's just flesh out some of the people that will be using it. So we're going to have, we're going to have the, let's just say, I don't know, whatever you want to call them, senior pastor or priest, senior pastor, any clergy leader, okay, and who else? Let's see. Bible study leader. Leads classes. We also have worship leader for any particular people. Music, choir, things like that. All these different people. It's good to call these out because we have these in our head, but if we don't put it down, we can't ramp up new people and have clarity. Okay, children's pastor. Okay. And sometimes I will leave this pane open just because it's good to see it. It's good to see it closed. Okay, so what is going to be the system?
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
Digital signage and printed bulletin. Okay. And external systems. Right now, the external system is going to be, we need to have a printer. You know, sometimes you can leave off descriptions if it's sometimes like, well, the description is kind of duplicative. Sometimes you can, sometimes you can't. Just you have to kind of look at the syntax. And then we're going to have a projector or a screen. Let's just call it projector. Okay. And then we start to get IntelliSense here. So the church bulletin system is going to export to the printer and send. This is just the name of the relationship. So send PDF to print, and this is going to be whatever the protocol. Network printer. Okay, and rel for relationship versus neighbor. Neighbor just means put it beside. Rel means not. So we're also going to do church bulletin to projector. And this is going to be project or digital signage. And auto animated. Okay, so we can see it's changing. Now, even before we talk about the system, we can talk about the relationship of the different people. So the pastor is going to use church bulletin. Well, how is he going to use it? He's going to add sermons, things like that. Okay, and then we need 3 more. Bible study leader is going to be add classes, and then worship leader is going to add services. Yeah, some of these overlap, but the children's pastor is going to add Sunday school classes. And then actually, we have another person, and you know what, I'm just going to call it a volunteer, because a lot of times, in a lot of churches, it's a volunteer who's actually operating it. Prepares bulletins and projects announcements. Okay, so now we have that. Oops. So now we have the volunteer. operates. No, let's just yeah. Okay. All right, so now we have all the different people who are using Church Bulletin, and this is the system, and it needs to interface with an external printer, it needs to interface with a projector, and that's basically the system, okay? All right, so now that's our system level. Let's go ahead and save that off. All right, let's close these out. That's our system. Now, let's go to the container level. Let's grab our template. Let's just paste it here. And that is going to be, I'm just going to call this our deployment model, because most of the time it's really useful to do that. So our deployment model is going to be here. And what we're going to do, let me just show the diagram. So as we change it, we can see. And for the deployment model, I'm going to actually genericize and just leave it as some user for now. And so the external system, I'm going to ignore for now. It's not pertinent to figuring out how we're going to deploy this in production. The system boundary, let's just call this, let's just call this Church Bulletin. And the system container is going to be system container is going to be Church Bulletin. And sometimes if I'm working on multiple, I'll just call it system, and that's fine too, because Church Bulletin system, or I might call it, let's see, in this case, Church Bulletin .NET 6 Azure. All right, that works too. Actually, I missed the quotes and I got a syntax error. So this little guy will tell you save Alt D. It's not going to auto refresh. You have to. Oh, now what to do? Okay. Is that a special character? What did I do? Lines. Church Bulletin. Oh, 2 parameters. Just one. Well, now this is a pickle. What is? You just undo. When in doubt, go back. Oh. Oh yeah. Okay. When in doubt, just go backwards. .NET 6 Azure. There we go. .NET 6 Azure Church Bulletin. Yeah, that wasn't going to work. All right, just let me leave it as system. Okay, so now the containers that we're going to deploy is, let's just call it a database container. Let's call it we need something running on the server. If we have Azure SQL storing the data, and then we have Azure App Service, container service, or the web app service, we're going to have either way app service. Okay. And then we're going to have a UI. And over time, I want multiple modes, but this is going to be the app that people are using, the UI. So let's just call it UI. All right. So this is going to be database. We're going to do Azure SQL database, and then we're going to, and the diagram's getting messed up, I just kind of leave it. App service, web or container, and then this is UI /user app. And you know what? I know I'm going to want to use Blazor WebAssembly. I don't have to use that just yet, but okay. So now we have the relationships. We have let's just redo these. Some user is going to use the UI. Then the UI is going to be used in app service. Then app service is going to use DB. And that's basically how it goes. I am going to uncomment left to right because I kind of want this guy to look a little bit different. All right, so the system boundary church bulletin, that's the system. Okay, and the name of this is uses over HTTP, and then UI, the UI Blazor WebAssembly app is going to call calls over HTTP again, and this is going to be, let's just calls over TCP because it's calling on a connection string. All right, so now we've documented kind of how it's going to be running. All right, let's close this out and let's go down to, see, we just did container. So now let's go to component. Let's go up and so this is component, and this is going to be the Visual Studio project dependencies. All right. So component diagram, church bulletin. Okay. So I'm actually going to leave out a person on this because it's really the Visual Studio project dependency. And system external is going to be libraries. And can I think of a library that I might, you know what? PDF generator. I know I'm going to have a library for PDF generator. PDF library generates PDFs. All right, and then I have a container DB, which is a special C4 item, and it's a database. Yep. Okay. So container boundary. We're going to have actually 3 different container boundaries, but let me just generate this diagram here. Some user, I'm getting rid of that. And instead of PDF generator, it is, or instead of external. Okay, there we go. So now I have screen, some layers, some objects. Within the Visual Studio solution, I have each individual project, and each individual project is going to have dependencies. Okay, so we are going to call this the, you know what, I'm just going to keep it simple, Visual Studio solution. And it is going to be churchbulletin.sln. Okay. And within it, we already have core. All right. So, by the way, I'm gonna get rid of this as an example, and we have core, and we have core inner layer of onion architecture. Net standard 2.1 or net 6.0 if we can get away with it. Let's see. And then we're going to need some data. So we know that we need data access. Actually, I'm going to start doing some Pascal keys because these are proper names. or even though they're variables. Nope, I just changed my mind again. I'm going to keep them as variables. All right, so data access, and that's going to house in the framework. Yeah, and that is going to handle interaction with SQL Server. Okay, then to get SQL Server, we actually need a database project, and that's going to house database migrations. Wait, let's just call it database. Manage creation and migrating database schema. Okay, and then another component, we've already done this, unit tests. And tests all in memory logic. Okay. Component. We're going to need, just because we have data access, we're going to need some integration tests. And you guys may think, oh, when are you going to get to the code? Either you do this on the whiteboard or you do it verbally and then you have to ramp people up, but you just do this once, and this is the mechanism for sharing decisions. If you've ever heard of architectural decision records, these are creating a record of an architectural decision. All right, integration tests. Tests all logic that flows between different memory spaces. And of course, every process is a different memory space. Okay, so then we need, if we're going to really flesh this out, we need a data access project to manage the interfacing with a database. And then we need our, we have a data access, we have a user interface project, so UI, and that would be the user interface. Okay. Blazor WebAssembly, application. And actually, because that's Blazor WebAssembly, we need the API project. So it's yeah, actually it's the API, the shared. Okay. The API project, which actually calls, does the logic on the server side. Web API. And of course, on a Blazor WebAssembly project, there would be client, and then there would be server. So we probably need to, let's just go ahead and UI.server. No, I can't do that. UI server, UI client, just because the template's going to want us to do that. And so it's going to be API. Server project, housing, web, endpoints. Okay, so server, and by the way, I know the template calls for a shared project. That shared project, all the things that end up going in the shared project end up flowing down to core. Okay, so core becomes the shared project. So, do we need anything else initially? We need a way to start, actually, let's just start creating relationships. So our data access is going to PDF generator. We don't have any code to call to a PDF generator. We are going to need, we're going to need another project. Okay. Component. And that is PDF interface. Manages dependency to PDF library. All right. Now this is one of the important decisions in Onion architecture, that you don't take a third-party library and just shove it in your core project, because then all your dependencies get jumbled together. You isolate external dependencies. So let's go ahead and just start with this. You know what? To clean things up, for now, I'm not going to muddy the waters with this. It'll be a lot more clear once we have our basic standalone application, and then we'll go into how to interface with other external dependencies. So we need our data access to have a reference to core, and that's going to be a project reference. We don't need this other one. Oops. Copy, and then let's just put that here. All right, we're going to have some more project references. We have unit tests, which reference core. We have integration tests that reference core. Actually, we have the UI server that references core, and we have UI client that references core. Everything references core except the database project. As far as the database project, that is going to have a reference on the database. That's not going to be a project reference. That's going to be a connection string. And tool migrations, probably through AliSQL or DBUp. You know, those are pretty popular. Okay, so we have those. Now, integration tests, that tends to also reference UI server. And you know, I'm going to ignore test references just for now, because they can muddy the waters. But let's see if we need any other references. Yes, we do. We need the client, the UI client, to reference UI server. And this is through a project reference. And then UI server already references core. We actually need a bootstrap. We need a bootstrapper, so we need a startup project. Now, the .NET in general tends to have a UI project of some sort, whether it's WPF or ASP.NET MVC or Blazor. It always tends to have the UI project also have the responsibility of bootstrapping the application with the main program.cs, and anything that needs to be wired up from database or any other dependencies. Just by wiring up the dependencies and having to be the startup project, the UI project ends up coupling to every other layer in the application. We don't want to do that in Onion architecture, so we create a startup or bootstrapping project as a first-class citizen. So we're going to have app startup bootstraps dependencies and starts application. Okay, so the startup project then has a reference to everything, and that is what ties it together. All right, we only have to do this once and then we get into code. Data access, UI server, UI client. Okay, so now what does our diagram look like? It has app startup, integration tests, unit tests, database. We're going to add those in later, but everything references core. App startup references data access, API, user interface references API because it has those types. I think this reference may flip. I think this reference may flip. Okay. Where API is serving that API, that's kind of part of the interface. But either way, core does not reference anything. That's super important. Everything else is an interface to something. Data access is an interface to where we store data. The API is an interface for HTTP connections. The user interface is an interface to the person who's using the software. And so with Onion architecture, project-wise, we have the core layers that are clean, that are free of interfaces. And the Onion architecture originally took a lot of inspiration from other things going on in the industry back in 2008. Hexagonal architecture by Alistair Coburn was with ports and adapters was another term for hexagonal architecture. There was a big emphasis on having an adapter to an interface, or a port, which is a mechanism to go out to use something else. But we want to make sure that we don't have any libraries like Entity Framework or Blazor references or any ASP.NET or web make it into our core project. Our core project, we protect that strictly, because when we go forward and we create a MAUI iPhone and Android app, when we create a WPF app, or heck, even a console app, terminal app into the future, if we've accidentally put a dependency that's not very portable in core, we're going to have problems. And so our application, we're going to use, when we get to it, Blazor WebAssembly. But this is not a Blazor application. This is just an application. It happens to store data in a SQL database in Azure. It happens to have screens that are going to be Blazor WebAssembly. And then it happens to use some PDF generator library that we will choose to generate a PDF for a foldable church bulletin. But it is not any one of those applications. It is our application. It's a church bulletin application. And so we want to really protect that. All right, so I forgot one reference. Kind of like the obvious reference, isn't it? Data access needs to talk to the database. Okay, and that is going to be connection string. Okay, perfect. So we saved that. Let's close these out. And we're going to go ahead and do what we always do, which is commit. And we didn't even have to get into Visual Studio for this, but I do like having these available in Visual Studio. So let's go ahead and add a new solution folder. And let's call it Arc. And you know what, I always have to check to make sure it doesn't create an Arc folder, and it didn't. Good. Okay, we're going to add existing items. All right, and some of this in Visual Studio, you know, if you're adding them all the time, it's like, oh no, I got to add them. but let's just add everything. Okay, so we got that, and we're going to do our commit to master, all these extra files, added architecture diagrams. Yeah, there we go. All right, commit and push. And let's go back over to our actions. Of course, this took 2 minutes and 13 seconds. These should have kicked off automatically because they're configured to do that. And yep, so 1 minute 28 seconds, 1 minute 19 seconds, and these are in progress. So, okay. That is going to be all for this part. We learned architectural diagrams, and we're going to leave it there. Wow, that was a lot. Thanks for sticking with me on this one. The next part, we're going to jump into the code. We're going to create those Visual Studio projects. We're going to flesh out the Visual Studio solution, the project references. We're going to create our first entity, which is that scheduled gathering class. We're going to do our data access. We're going to configure in our first library dependency, which is Entity Framework. We're going to create our database schema using SQL Server database migrations. We're going to do a lot, but what you just saw was how to have architectural diagrams defined by text so that you can store the actual diagram documentation with the code of the application and communicate to any other person who works on the team what the overall intent is of the architecture of this application. So that was a lot. I encourage you to go and grab the templates of those PUML files, those PUML, PlantUML files, and start using them on your own projects. Use that PS1 shortcut for jump-starting and installing the tooling in using Chocolatey in VS Code. And any diagram is going to be better than no diagram when you're trying to communicate intent and communicate architectural decisions. So that was a lot of fun. God bless, and thank you for programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.